6th grade, and happy superhero or princess Thursday. Hopefully you guys are working on some costumes or outfits that you'll send in some pictures for that later. I love seeing what you guys come up with. I want to go over your class notebook assignment today for Punnett squares. So in the class notebook, as usual, make sure you're under your own name and in handouts. And if for some reason under handouts you are having a hard time finding this new page called Punnett squares, remember that if you just hit add page and add a blank page, it forces everything to refresh. So I'm sorry there's not a better way for that here, but it forces it to refresh, and then the Punnett squares page will pop up. So if you're having trouble viewing that, just take that step, and then if you're still having any trouble, feel free to let me know and I will help you out. I'm going to go into my page though, and looking here, it's not a long assignment, but you may be having some trouble understanding what to do with these squares. I know it says what to do in your textbook, but I want to show you exactly how to do it. And what a Punnett square is, we've talked about Mendel's research on genetics and how the parents pass down traits to their offspring to make it more easy to understand or mathematical. Reginald Punnett developed this system that can tell us if we know the genotype or the genes of the parents, then we will know within a relative amount of certainty the percentage of traits to be found in the offspring. So we'll know what percent of the offspring are going to be tall and what percent are going to be short, in this case of the pea plants. Here how to make a Punnett square, and hopefully you stay and watch to the end, because I'm also going to be solving one of your homework problems with you. So let's go through, and I'm going to make a couple of drawings. Here's a tall plant, and here's a short plant. Now remember, tall and short are the phenotype, what it looks like. We don't necessarily know the genotype of a tall plant by looking at it, but we do know the genotype of a short plant. Again, we're only talking about these pea plants here. All plants have different genetics that work differently. But we do know that if it's a short plant, it has to have 2 recessive traits. Why? Because remember, whenever the dominant trait tall shows up, it's going to bully or it's going to overpower the recessive trait. And so the plant is going to look tall. So there are 2 possibilities for genotypes for this tall plant. One is that it got a tall gene from each of its parents. We would represent that with 2 capital letters, and it doesn't matter what really the letter is that we choose. We choose T because T for tall, but we're not going to do S for short. Instead, for the recessive trait, we're going to do a lowercase. So the other possibility is that it has 1 gene for tall and 1 gene for short. Remember, we call this one hybrid and this one purebred. Now, the only possibility for the short plant is that it is purebred with 2 short genes. So we have to have purebred short in order for the phenotype or the physical characteristics of the plant to be short. So these are the phenotypes: pH, physical characteristic. And if you match those up, hopefully it helps you to remember it. Whereas these are the genotypes. Or the genes that are passed down from the parents. Anything that has 2 of the same, purebred. So this is purebred. Over here, this one's purebred. And then this one, since it has 2 that don't necessarily match, is hybrid. Let's get to making a Punnett square. So let's mix 2 plants And I'm going to make my Punnett squares red, I think. All right, let's mix two plants that are both purebred, but one is purebred tall and one is purebred short. So you notice one parent goes up here and the other parent goes down here. After that, it's kind of like a puzzle where you put it together, okay? So I'm going to put together the two that are touching this square to find out what 25%, because there are 4 squares, of their offspring would look like. So I've got uppercase T, lowercase t. I'm always going to put the uppercase or the dominant trait first, even though I could have more easily, like if it was in the reading direction, you might be tempted to put this lowercase first right here. Don't do it. So capital T, lowercase t. Then we've got over here, capital T. Then we're going to come from over here, lowercase t. Hopefully it's making sense. For this one, I'm going to take from up here, capital T, and from here, lowercase t. Then for this square, I'm going to take from here, capital T, and from here, lowercase t. Now, all of the offspring, 100%, because it's 25%, 25%, 25%, 25%, since it is a quarter each, okay? There are 4 squares here. But 100% of their offspring will look, or their phenotype will be, tall, and their offspring will all be hybrid because they've got one gene for tall and one gene for short. Hopefully that makes sense. So their phenotype or the way they look will all be tall. This was the F1 generation that Gregor Mendel was talking about. The F1 generation was a mixture of purebred tall plants and purebred short plants. So what happens then if we mix hybrids together? Let's get 2 hybrid parents. So both of these parents look tall. And if you didn't know their genotype, you might think they were purebred tall. But you're going to be able to tell by their offspring that they're not, because look what happens. I'm going to take this T and this T over here. And bring this one down. This one over. And then my last square is going to be interesting. So for this Punnett square, I've got 2 purebreds. I've got one purebred tall plant and one purebred short plant. But then I've got 2 hybrids. However, they look tall. So if I'm going for phenotype only, or the way that they look, I have 75% or 3/4, 1, 2, 3, of my square that looks tall. And I've got 25% or 1/4 that looks short because it's purebred short. Remember, that was the F2 generation because Mendel mixed together the offspring of the F1 generation, and he found out that that hidden gene or that recessive gene did show up, albeit in just a small percentage of the offspring, but it did show up. So let's look at genotype then. The genotypes are 25% purebred tall. That's capital T, because there's only one that's purebred tall right here. And then you've got 25% purebred short. That's lowercase t. And then you've got 50%, because it was 2 out of 4 or 1/2, hybrid. And both of those hybrids, remember, their phenotype is going to be tall because that dominant gene is present. Finally here, I am going to go over one of these homework problems with you. So let's do number 1. And it's showing that both parents are hybrid. So we've already done one of this. However, it's not going to be the tall and the short that we've already worked with. It's actually about hair, straight or curly hair. And you'll notice that capital H is curly hair, meaning that it is dominant. And the lowercase h is straight hair, which means straight hair in this case is recessive. So we're going to see what the chances are. They both have curly hair, but they both are hybrid for curly hair. So we're going to see what type of hair their children have and what the chances are that their children will have that type of hair. So I'm going to, as usual, I'm going to double click and insert text. So here, if I take the H and the H, I'm going to have capital H, capital H. Here, let me make a new one. And drag it over. I'm going to have one capital H and one lowercase h. Here, I'm going to have one capital H from up here and one lowercase h from over here. And finally, I'm going to have two lowercase h's. So now I can tell exactly what hair types the percentages of their children will have. And it's really likelihood. So it's not going to be that they have 4 kids and their 4 kids are going to have this hair exactly. It's just the chances. And the chances that their kid is going to have purebred curly hair is 25% because it's 1 out of 4. The chances that they're going to have hybrid curly hair, 50%. So that's the chances they'll be exactly like their parents. But what will their hair look like? It will look like curly. So there's a 75% chance, or 3 out of 4, that their kids will have curly hair. However, there is a small chance, since they're both carrying the recessive gene, that their kids will have straight hair. And that's just a 25% chance. So I'm going to put the probability down here. So the probability of a curly haired kid is 3 out of 4, or if we convert that to a percent, 75%. All right, hopefully this video helped you, and if you have any more specific questions, feel free to ask me in the chat.